Now let's go through a calculation. Again, in your flask, you'll have your white powder, your chloride sample, and you'll have to know the mass that is in that flask. The water, the amount of water doesn't have to be exact, but get it close. It doesn't react, so that's why it's not as important. And then the potassium chromate, this is your indicator. In your burette, you're going to have your silver nitrate, and you should fill it for each time you do a trial. Start with it near the zero. It can't be over, but it can be like up in the space above the top line, but it can be slightly under, and record that exact the volume, 2 places past the decimal. And then you have to know this concentration. This concentration of your silver nitrate is on your bottle. So be sure to write that down because you'll need that for the calculation. And then the idea, this is the volume before, and then when this turned like a peach color, I stopped and I record the volume of silver nitrate now. So how much did I use? What volume was added? So I just subtract the final minus the initial. And then I'm going to do my stoichiometry to determine how much chloride was in there. So I need to know how many moles of silver nitrate that was. So I'm going to start with my volume. And this last number, this is from the molarity that was given on your bottle, this number here. Okay. And then the next question asked me, how many moles of silver ions does that have? And just looking at the formula, I can tell that for every silver nitrate unit, there is 1 silver ion. So this will actually just be the same number. And then it wants to know how many moles of chloride reacted. Well, if we remember our net chemical reaction, it is a 1-to-1 mole ratio, so it's going to be the same number again. And then we need to go to the mass of chloride because we're going to want the percent chloride by mass. So we need to go to grams. And then you might say, well, what do we use for the molar mass of chloride? Well, we'll use the atomic weight of chlorine, but we're going to use more sig figs because at this point you probably have 4 sig figs, so let's not round that off. Okay, I have been carrying extra digits, not that big a deal. Okay, so what's the percent chloride in our unknown? So what we do is we take the mass of chloride, which we calculated. Oops, there. Divided by the total mass of the sample. And so let me just label this. And for this one, it was okay, I'm going to show you where I got that number, just to remind you where that comes in. It was the amount of the white powder that we put into that particular flask. This amount will be different each trial probably, so you'll need to keep track of which one, but that's the end of the calculation. Now I've got a little bit more notes to help with some of the post-lab stuff as well. Okay, so is it possible to have a sample that is 100% chloride? And so I'm like, is it possible that your sample that you get could be pure chloride? And no, it's not. Why? Because chloride is chlorine with a -1 charge. You know, chlorine is the element. And it would be possible to have 100% chlorine, but this is chloride. It has to be in an ionic compound because this is not neutral. And so it would be very, very unstable. It must have some, if you have a chloride, something with chloride in it, there has to be a metal cation with it to stabilize the crystals. So don't expect your values to come out 100%. It can't be 100% by mass chloride. Okay. How could we determine the percent chloride by mass? You see, we can't just look at the formula and do that because we don't know what X is. Ours is unknown. But what if we did know, just kind of thinking of our other way and what we're doing? How would I get the percent chloride by mass of this? And we actually do this, back when we were learning our first calculations, determining percent by mass. What you do is you calculate the molar mass of the whole thing, and I'm going to use a lot of digits here. And this is for the sodium and the chlorine. And this is the grams per mole for the sodium chloride. And then to get the percent chloride, you would take the mass that was due to chloride, this one, divided by the total, times 100. And that's the percent chloride by mass. Okay, and then my next question is, will all samples, if we have sodium chloride, will it always have that percent chloride by mass? And yes, because that is a set ratio for sodium chloride, we will always come up with that. So if we wanted to know if our sample were sodium chloride, we would see if that's what it comes out to be. If we wanted to know if our sample was maybe potassium chloride, we could do the same thing for it. But your sample may be a mixture of chlorides. It may have sodium chloride, lithium chloride, kind of all mixed. They would all be chlorides, and that's what we're determining. Okay, the last thing is just an important clarification about how we set up the experiment. And get our samples, because you're going to do 3 trials, and each time you have a trial, you'll have a fresh flask with a different amount of sample in them. You're not going to happen to have the same amount. And so how we do this is kind of different. The first thing is that we may call our test tube, or we have a tube, we may call it a vial, it may be more of a tube, just be aware that. Okay. And instead of weighing how much we get in weighing our flasks, our 3 flasks for our 3 trials, we're going to weigh our container. So what you do is you get the initial mass of the container. So that's what it is with all of it in there. And then you sprinkle some carefully, not too much. You try to go for about 1/4 in your first flask. And then you weigh your container again. Okay, and then whatever mass that is, you can take that number and put it here. That's its mass before you sprinkle in the second one. And whatever mass that you then you weigh again. So you're weighing in between each one. Sprinkle some in the last one. Okay, so be sure you're recording those. You starting mass, sprinkle some, write down that mass. You'll use that here. Sprinkle some, write down that mass. Use that mass here. Sprinkle some, you get that mass. And then to get your masses for each one, you're just going to subtract the numbers above. And again, it doesn't matter that you have the same amount in each one. What matters is that you know that flask 1 has 0.25, so that when you do your calculations for flask 1, and the other thing is I'm going to expect, since my flask 1 has more sample, I'm going to expect it to take more of my silver nitrate solution to get to my endpoint.